Hello, welcome to Maths 3. Let's put that down here. Okay, so what I want to talk about here is I want to go and talk about this right here. So we've got A over B plus or minus C over D. Remember when we do, these are integers, these A, B, C and D. And they're also, so it's rational numbers basically. That's the set we're dealing with. So we've got the, we've got if we imagine that A over B is like it's just integers over each other, and it's rational numbers. So these are numbers which can be expressed in a rational way as one integer over the other. Okay, so we've got A over B here, times D over D. Plus or minus C over D times B over B. Okay. So let's just, for the sake of it, just assign some random values here. We'll have 2, 3, 5, 7. Okay. So let's do a work example here. And we're just going to say plus for now. So do 2/3 plus 5/7. Okay, so that's going to be 2/3 7 over 7 plus 5/7 times 3 over 3. So yeah, so that is how it's going to work. Now if we look at this here, you need to think, what can this be reduced down to? Okay. And the answer to that is the following. AD plus or minus BC over BD. So let's just remind ourselves of our numbers again. We're going to be dealing with 2, 3, 5 and 7. So let's plug them into this. Again, we're going to be doing plus here. So going to have 14 plus 15 over 21. So what do we get then? 29 over 21 is 1 and 8, 21. We could just put 20, well, let's not do that actually. Let's just put 29 over 21. So yeah, so 2/3 plus 5/7 is 29 over 21, I guess. I mean, yeah, yeah. I suppose the other way, yeah, how would I normally do that? You can also say shit like this. You can just do, you can do this way. But it's actually the same, isn't it? Yeah. Just put everything over 21. But to be honest, Yeah, this is more like it, isn't it, really? So yeah, let's try a subtraction one then. Let's try 6/7 minus 2/3. All right. So we're going to do 18, and then we're going to do 14 over 21. That's 4 over 21. And yeah, you can see that if you do so. Yeah, I mean, in fact, it's sort of the same because you're gonna multiply these two here, 21, and then you're gonna to get the denominator, and then you're gonna multiply these two here um, to get this number. And you're gonna multiply these two here to get this number. And that is, yeah, I mean, that's basically what's going on there. Um, yeah, I mean, new multiplying. Yeah, so there's not a huge amount of ways to talk about that, I suppose. Um, what else can I talk about here? Um, well, yeah, I mean, I shouldn't. Yeah, I shouldn't have used that mixed number there, but anyway. Um, so yeah, and there's obviously things like if x squared um, is 2, just very very simple things, then the x is going to be plus or minus the root of 2. Um, yeah, so there's another thing. Of course, I'll talk about this some more. And we've got real numbers. This is a massive fucking R. So yeah, I shouldn't really swear actually in these things. Massive R. So it's going to be a set of rational numbers. Plus all irrational numbers. So yeah, and yeah. Okay, so what can we say about this set? Well, it's an ordered set. So when we talk about complex numbers, we're gonna be going through something slightly differently. But it's an ordered set. So we've got positive numbers, 0 of course, negative numbers. So we can put anything in there. We could have we'd have pi over here, minus 3/7 over here, for instance, whatever it may be. And we can make some sort of generalized statements here. So given A and B are in R, how can we deduce what the sign of the final answer will be? Well, if A is greater than B, well, we can say that yeah, this is like inequalities now we're dealing with. Okay. Okay, so well. So A is greater than B if A minus B is positive. So let's put some numbers there. We can see that 7 minus 3 is 4. So the answer is going to be 4 here. So that's true. And then we can say that A is greater than B, which it is. A is equal to B if A minus B is 0. And A is less than B if A minus B is negative. So the middle one is fairly self-explanatory. There's just the same number here. If we put in a 3 and a 7 here for the bottom one, we can see the result is going to be minus 4 here. And so we'll be able to deduce from this negative answer that A is less than B. Okay, and yeah. And so, for instance, we may get a situation where you want to actually sort of define some sort of range. So we have a number line here. And we got some values. And then we sort of said like, well, x. We want to find. It'll be like find x, right? Well, find x on the number line. So yeah, so it might be a question to saying, you know, where are we going to find x? What values of x are okay? So, and we're told this. So this sign here is less than or equal. So you can have less than or equal, greater than or equal. Obviously the one here is less than. Obviously one here is greater than, and then this one is yeah. It's basically yeah. So the way it works really is that if you're sitting over here, if you're sitting in the middle right here, then this is going to look like greater than. If you're over here, then this is going to look like less than. This is saying I minus 1 am less than x. But x is saying I'm greater than minus 1. But they're actually saying the same thing. But yeah, they still are saying two things. So it's always good to look at all perspectives in these things. So we know that x is greater than minus 1. So let's look at the other side then. It's less than or equal to 3. So it can be equal to 3. So we'll do a little ball there and we'll fill that in because we're going to say, you know what, 3, that is completely fine. What about if x is 2? Well, yeah, it's less than 3. Yeah, the same with 1. Yeah. So all this range is fine. But what about when we get to minus 1? Well, there's no line underneath the sign here. So x has got to be greater than minus 1. Being minus 1 is not an option for x. So there's the answer. And we say this is going to exclude. So in other words, we could say, yeah, I mean, if we are like, say we, just for the sake of it, we'll just assume integers. Then it would only be, if we could only have integers, it would only be 0, 1, 2, and 3. 3 is allowed, is inclusive, included, 3 included, -1 excluded. And that is what we talk about with inequalities. And we can also even say, we can even say other things, like we could say, or x less than -2, or well, how about if it's greater than 5? So we could have, to do another number line, we could have -2 over here, 5 here. So it's got to be less than -2. So put that there. So all this stuff is fine. This is excluded. It's got to be greater than 5. So all this stuff is fine. Again, excluded. So it doesn't have to be in, it's not like, it doesn't have to be a continuous block, continuous range. And that's what we want to talk about here. So what I'm going to do is I'm just going to wait a few seconds because the recording for some reason chops off a bit of the time at the end. So I'm just going to wait about 20 seconds here. So we'll see when it ends.